Hello everybody, my name is Wendy Carolina Vázquez, and on behalf of my research team from the Universidad Autónoma del Estado de Hidalgo and our collaboration, I am pleased to present our work. The main objective of this study was develop and structure characteristics and novel nanocomposite based on gadolinium substituted hydroxyapatite and reinforced with graphene oxide. This is to evaluating its potential relevance for semiconductor-based applications. To achieve this, we follow the methodological route shown in the center of the poster. On one side, the gadolinium substituted hydroxyapatite was synthesized by an hydrothermal method and a calcination to obtain the dust of the hydroxyapatite. On the other side, graphene oxide was obtained from graphite using a modified Humer's method. Both components, the hydroxyapatite and the graphene oxide, were then mixed in different concentrations of graphene oxide using a ultrasonic bath. Moving on to the structural characterization results and the extractive reaction patterns shown the presence of highly crystalline hydroxyapatite with hexagonal and monoclinic phases. The successful incorporation of gadolinium is evidenced by lattice distortion and defect, which is directly influence the crystalline size, which depends directly of the dopant concentration. Furthermore, we can observe the characteristic peak of the graphene oxide around to 10 and 12 degrees. In another technique, the FTIR spectra confirm the successful synthesis. We can clearly identify the bands corresponding to the phosphate and hydroxyl groups of all the samples in hydroxyapatite. And the carbonyl, epoxide, and hydroxyl functional groups from the graphene oxide. This material combination is critical. The gadolinium substitutions influences the band structure and charge carrier behavior, while the graphene oxide provides a high surface area and acts as a conductive network that facilitates the electron transfers. In conclusion, gadolinium substituted hydroxyapatite was successfully synthesized via a hydrothermal route, and graphene oxide was successfully produced using modified Humer's method. The resulting composite exhibit key structural factors that are highly relevant to semiconductor-based technologies. Finally, we are gratefully acknowledge the financial support provided by the CCT and Citnova through the project indicated. Thank you very much for your time, and I look forward to your questions in the WOBA platform.